Today let us discuss about valid anagrams. So first of all, let us know what is anagram. Anagram is nothing but two words having same frequency of letters with the same length. The letters in the words may be zigzag. So suppose if you take example anagram, first word is anagram and second word is nagaram. So the letters possessed in the words are same. The frequency is also same with the same length, but the words are zigzag. So this is called anagram. If you take this one, rat and car, this is not anagram because there are two different letters are there. Here, rat, car. Rat, in the rat, T is not present in the car. R is not present in the rat. Only R. A is present. Common is A. Just A is common. So that doesn't sense. That doesn't make sense. That is anagram. So we can achieve this. We can write all this in by taking the count array. We can do it in different ways, but let us do it by taking a count array. So let us take the count array of size 26 as the size of the number of alphabets is 26. Let us take 26. So what we will do is for the first word, we will increment the index of the count array. Suppose if we take A, what is the alphabetic number of A? 1, right? So in the first index, we will increment the count. Likewise, so if we increment, how many A's are there here? 3, right? So at the index 0, the count will be 3. Uh, count at index 0 equal to 3. So next n is there, right? At index, what is the alphabetic number of n? Alphabetic number of n is 14, right? So as array size starts from 0, we will consider 13. At index 13, we will increment 1. And likewise, what is the alphabetic number of G? At the index 6, we will increment 1. Also alphabetic number of R. R is 18. So at index 17, we will increment 1. What is the alphabetic number of M? 13. So at 12, we will increment 1. Likewise, for the first word, we will increment the indexes in the count array. So when we increment at index 0, 3, at index 13, 1, at index 6, 1, at index 17, 1, at index 12, 1. Likewise, for the second one, we'll decrement the count. So say what is n? What is the alphabetic number of n? 14, right? So at index 13, we'll decrement 1. So at the index 0, we'll decrement 3. At the index 17, at index 17, that means R, will decrement minus 1. Likewise, if you do at every index, the count get cancelled. So if the count array remains 0 at every index, then it's said to be anagram. Otherwise, it is not an anagram. Suppose if you take R, At R index, we'll increment. At R index, we'll decrement. So these two get cancelled. At A index, we'll increment. At A index, we'll decrement. So these two get cancelled. At T index, we'll increment. At C index, we'll decrement. So at the 2 index, there are 2 index with non-zero values are there. So whenever we'll encounter non-zero values in the array, then it is said to be non-anagram. It is not an anagram. So let's code this. First of all, what we have to check? We have to check the length. If the length itself not equal, then it is not said to be anagram, right? If length of first word is not equal to the length of second, then we will return false, right? So now what we have to do for the first word, we have to increment the count at indexes in the count array indexes. So we'll write a loop. I use a question. I use the let's go. What we have to do, we have to implement the count at index. Why we are doing like this here? Because the ASCII value for the small letters ranges from 97 to 122. So, for suppose if you take A, the ASCII value of A is 97, right? 97 minus 97 get cancelled. What is the value? 0. So, in the count array, at the 0 index, get incremented. So, likewise, it does. So, for the second word, we have to decrement, right? So for the second word, we have decremented the count. So now we have to check for whether there are any non-zero values in the array. If there are any non-zero values, we have to return false. Otherwise, we will return true. So right there with true. If we encounter any non-zero value, right, we have to return. So otherwise, we'll come out of the loop and we'll return true. So understood? What we are doing is in the count array for the first word, we are incrementing the alphabetic number indexes in the count array. For second word, we are decremented. So if the frequency of these two words are equal, then they get cancelled. At last, if the count array gets zeros in all the indexes, then we'll return true. Otherwise, if we encounter any non-zero value, we'll return false. That is the problem. So test cases and cards. So this is the problem, and we have completed in the optimal way. Thank you.